So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem of the day, and the problem is max sum of pair with equal sum of digits. And in this problem, we have to given a zero index array nums, and we have to consist of positive integers, and you can choose two indices of I and j such that I not is equal to j, and the sum of digits of the number nums of I is equal to the nums of j, and after that we have to return the maximum value of nums of I plus nums of j that you can obtain over all possible indices of I and j that satisfy the conditions. So now let's look at their problem statement, then we have to further looking their example test cases so that you can understand their problem statement basically. And so first in this problem we have to given a zero index array nums, and we have to consist a positive integer, okay, and you need to find the two indices of I and j, and this I and j is I not is equal to j, okay. And now the zero index means the first element of the array is at index 0, and the second index is 1, and this is our zero index array. And now positive integer means all elements in nums are greater than 0, and then sum of digits, this sum of digits means the sum of all digits, all digits number means like you have to adding all digits basically. If you have to given uh, 36, okay, and this 36 you have to add 3 plus 6 is equal to 9, so this is the sum of digits, okay. And now we have their maximum value, and this maximum value of nums of I plus nums of j, it means among all valid pairs we take the one of the largest sum, okay. And now this is we have to find, and now our goal is to identify the pairs of I comma j where sum of digits, this is sum of digits, and this sum of digits is our nums of I is equal to nums of j, and this will be we have to find here, and then find the maximum sum of and then find the max sum of nums of I plus nums of j, and after that if no such pairs exist then we have to return -1. So I hope you understand the problem statement. Like first we have to find their pairs, and after this we have to sum of their digits, and if it is equal to nums of I is equal to nums of j, then we have to find their maximum sum, like we have to adding nums of I plus nums of j, and if it is maximum then we have to return this, and else we have to return -1. So this is our goal, and now this is our example first, and this example basically we have to given a nums array 18, 43, 36, 13 and 7, and here we have their index 0, 1, 2, 3 and 4, and now we have to calculate their sum of digits basically. So in 18 the sum of digits like 18, 43, 36, 13 and 7, and here 1 plus 8 is 9, and 4 plus 3 is 7, and 6 plus 3 is 9, and 3 plus 1 is 4, and this is 7, and this is our sum of digits. And now what we have to do, we have to do like this 18, 43, 36 and 13 and 7, and now we have to write it here their digit sum 9, 9, 4 and 7. So here we have to find their pairs where nums of I is equal to nums of j. So basically here 9 is here and 9 is also be here, so we have to add this both pairs, like this is our index 0, 1, 2, 3 and 4, so we have to 0 comma 2 with value of 18 comma 36, the sum of digits is 9, okay, the both sum of digits is 9, so 13 plus 36 is equal to 54. Okay, and now the second, this 7 and this 7 is same, like nums of I is equal to nums of j. And after that we have their pairs, the pairs, and the pairs is 1 comma 4, and this 1 comma 4, the value are 43 and 7. The 43 and 7 is equal to what we have to their digits, the digits are 7, and the nums of I plus nums of j. Now nums of I is 43 plus 7 is equal to 50, and now this now remain is 4. This 4 we cannot get any pair, like this nums of I we have to get 4, but nums of j is not present on this nums array, so that's why we can discard this 13, and we cannot process this 13. Okay, and now after that we have to find their maximum. The maximum of 54 comma 50 is equal to 54, so this is our answer, this 54 our answer. Okay, so I hope you understand the example 1. And the in second example, first we have their values, so 10, 12, 19 and 14. So 10, the sum of this one is 1, and 1 plus 0 is 1, and 12 is 1 plus 2 is equal to 3, and this 19 is equal to 10, and this 1 plus 4 14 is equal to 1 plus 4 is equal to 5, and this is our sum of digits. And now you can already computed their sum, but no two numbers have the same sum digits, so we can return -1 directly, because there are no any valid pairs are present here, so then we have to return -1. So the brute force approach of this problem is, so we have to iterate through all pairs of I comma j, and after I comma j we have to check with their sum of digits of nums of I is equal to nums of j. And after this we have to keep track of the maximum sum, like this is taking O of n square time basically. Like what we have to do, first we have their int sum of digits, and this sum of digits is int n taking, and this int sum is equal to 0, and after that we have their while loop of n greater than of 0, and this sum plus is equal to n mod 10, and this n by 10. Okay, and then after that we have their return sum, and we have to calculate their sum basically. Let's suppose this is 10, then we have to find here sum. Okay, both two values, and then we have to call it here basically int answer is equal to 1. Then we have their for loop I to n, 0 to n basically, and this one is for I plus 1 to n, and then we have to call this one. Okay, this sum of digits of nums of I is equal to nums of j, and after that we have to return what we have to get here, answer is equal to max of answer comma nums of I plus nums of j. So after that we have to return answer. So we have to get our brute force code. This is our brute force code for, like what we have to do, we have their sum of digits, and after sum of digits is, if sum of digits are equal, then we have to compute here, like we have to plus both the pair value, and then we have to we have to find maximum here. So it takes O of n square time. Basically we have to calculate with two for loops, and this is a brute force solution, basically not feasible for 10 to the power 5, because the constraint we have to given constraint are 10 to the power 5. And now this is O of n solution, and this is getting TLE. And now what we have to do, we have to optimize this code for O of n log n, or you can say O of n. And this O of n log n solution is basically what we have to do. We have basically use a priority queue. You can use of a map of priority queue, so that you can track the values. And this priority queue basically for max heap for storing the number with that sum, and iterate with all the values. Okay, now let's look at their code for priority queue. And here, so first we have to create a hash map. This hash map uh, to their group numbers by their sum, and after inside this we have their priority queue for track the values. And then second we have their answer is equal to -1, because default the no valid pairs are exist, so that we have to answer is -1. And then we have to iterate all over the numbers, here all over the numbers. Then we have their sum, we have to initialize with their sum is 0. and, and then we have to compute the sum of their digits, here sum of digits, and this sum of digits, and we have to add the sum, here we have to add the sum, and then we have to remove the last digit. Okay, and this is the simple, we have to find their sum of their digits, like 54, 72, and so on, like this one. And now we have their store, here we have to store the current number in priority queue, current number in priority queue of mp dot sum dot push nums of I. And then we have there, if we have at least two numbers with the same sum of digits, at least two number, okay, greater than equal to 2 means nums of I is equal to nums of j, you can say two pairs basically. Okay, and then we have there get the largest number, here they get the largest number, and then we have to remove the largest number, and then here we have there get the second largest number, we have to store it into our priority queue, and then we have to find their max. Okay, max of this p and this q and this answer, and then we have to return the final answer. And now how it is actually work, it is like first we have to check this one, how this will be work. And this let's suppose n is equal to 36, and this one is 3 plus 6 is equal to 9. Basically we have to extract the digits, first digit, second digit, and then we have to find their maximum sum. Okay, sorry, sum, only sum. And then this one, and this p of mp of sum dot push nums of I, and this will be work this one. First we have their key, and the key is sum of digits, and after sum of digits the priority queue of mp of sum, and we have to store the same sum of digits basically for uh, here we already discussed this one, but 18th, 43, 36, and 13 and 7, here is we have sum of digits are 9, 7, and 7, 7, and 4. Now we have their priority queue, and this priority queue of max heap basically for this 36, and this 18. Okay, this 36 and this 18, we have their same pair, same sum, then we have to store into our priority queue, and 36 is at top. Okay, because first we have their 18, then 36, we have to store it here, and then with the same pair of 7 and 43, and 43 and 7, and 43 is our top. Okay, and then we have their 13, and this 13 is our 4. Okay, and we have to store it our priority queue. And now we have their values first. Okay, here we have to update it as far as like how this first example is actually work on this priority queue, how we track the our example test cases basically 18, 43, 36, 13, and 7. 43, 36, 13, 7. Okay, and this is our example. So our first iteration 1, we have there 18, and this 18 sum of digits is 1 plus 8 is equal to 9, and this our map is this map. Okay, this unordered map int comma priority queue of int mp, and this mp is become 9 of their 18. Okay, this is our sum value, and then this is our actual value. And this iteration 2, we have their process with the value of 43, and here 43 is 4 plus 3 is equal to 7. And now what we have to get, mp of 9 is our 18 and 7 is our 43. Okay, and this our iteration 3, this iteration 3, and this iteration we have there process the value of 36, and this 36 our map is 3 plus 6 is equal to 9, and this is 9 is our what we have to get, this 36 comma this 18, and now this 7 is 43, this 7 is 43. And now found the pair of this 36 and 18 we have to get here, and now we have to calculate their sum. Here sum is equal to 54 and the answer is equal to 54. Current answer is 54. Okay, and now in our next iteration, this iteration 4, iteration 4 is our the value is 13, I guess. Yeah, 13. 13 is our 1 plus 3 is equal to 4, and this mp is now mp is 9 is our 36 comma 18, and the 7 is 43, and this 4 is our 13. Okay, and after next iteration we have their iteration 5, and this iteration we have their value 7, and this 7 is only one value, so the sum of digits is only 7. So mp of 9 to 36 comma 18 comma 7 is our 43 comma 7, and this 4 is our 1 comma 3, and this will be become one more pair we have to get here, like sorry, this is 13 only, only 13, and one more pair we have to get here, 43 and 7, 43 plus 7 we have to get 50. And now what we have to get, we have their answer is equal to, we have to max of the previous answer comma this answer. So 54 comma 50 is equal to 54 is our answer. So I hope you understand the logic of this priority queue solution and as well as their brute force solution, like how actually we have to compute the sum of digits and their two for loop approach. Okay, and now the time complexity of this optimized code is, the time complexity of this code is, so first we have to compute the sum of digits. It is taking O of log n time, and this O of log n time is equivalent to O of 1 time, you can say, and the inserting into a priority queue, it is taking O of log k time, and where k is number of element in our group, and this overall time complexity of this code is O of n log n, because since this n like insertion happens at most n time, so that we have to getting here O of n log n our time complexity, and the space complexity of this code is, we have O of n space complexity because of the hash map are storing our nums, so that we have their space complexity of O of n solution. And now why we have to take this priority queue? So basically we have to taking the priority queue always the keep the largest number on the top, and efficiently we have to retrieve the top to largest value. Okay, top to largest value, so that we have to use a priority queue solution here. And why unordered map of priority queue, unordered map of int priority queue? Because of efficiently we have to group the number of some of their digits, like we have to group it here, like first if 9 is here, then we have to group with 18 value, okay, actual value. So after that we have to reduce our time complexity by using this solution. So I hope you understand the logic and the implementation part. So thank you everyone, thank you so much.